Hello, hi guys, how are you? How's the Josh? Are we feeling high?
Who's your favorite?
Hello guys, hello. Let me see if I'm audible. Yes. Hello. Let me see if I'm audible. Yes, I always recommend Holland Night. So in this lecture, guys, we are going to study divisibility tests and cyclicity. These are two very important points of number theory. In fact, for next few lectures, we are going to study number theory. I have covered basics of algebra. For next few lectures, I'll be covering basics of number theory. SPS sir is covering basics of geometry. So these are the three essential elements which you require to basically master IOQM level of mathematics. My name is Prashant Jain, author of 19 plus books, most viewed IOQM educator since last 4 years, mentor of AIR 1, 6 and 22 in ISI BMAT 2023, mentor of numerous top 100 ranks in JEE 2023, INCHO Gold Medalist, INPHO NTSE Qualified. So yes, like these are the links, guys. This is my Telegram link. First of all, you should definitely go and like subscribe on this and enable the notification as well, because all the videos related to me you can find on this particular link. IOQM PYQs, assignments, mock tests you can find here. NSCGS, NSCP, NSCC, NSCP. So we have free resources for all of you for all the Olympiads that you want to target. If you want to join the Ramanujan batch, guys, this is a live learning batch, two-way interactive batch. Class mode is online. Olympiad Goal, you can subscribe to Olympiad Goal. You will be given a learner kit, online and offline it is. One t-shirt, printed study material and iCard. Tuesday, Thursday, Saturday, 5 to 6:30 p.m. This is a fixed timing and it is on Zoom. So it is not a usual platform subscription. It is a very superlative product, and there are live tests. You can give the test in nearest offline centers also. So it is a hybrid batch that way, right? Let's get going, guys. And this is Foundation Centers Live. If you want to enroll for 8th, 9th and 10th, right? So this is a Centers Live. It is for this also you need to take 1 year Olympiad subscription. 1 year Olympiad subscription. In the description, you can find the link of these batches. Basically, for everything you just have to buy 1 year subscription of Olympiad Gold. Using the code PJ Live, you will get extra discount on it, 5% extra discount. Right? Where is the marker? Just a second. Yes. So PJ Live is the code which you can use, right? It is available in the description. The code is pre-applied, so you do not have to worry about it, right? Guys, this session is every Monday. Every Monday I am taking live lectures of IOQM, live lecture of IOQM English, but in English, so that we can cater to the broader audience. My Hindi lectures are already available. They are being scheduled every Monday, Wednesday, Friday in the same channel from 7 p.m. to 8:30 p.m. largely. But these are my live lectures. So if you want to attend my live lectures, this is the time. And I will be answering your queries here also. I have your chat in front of me, right? So let's get started, guys. I believe we can get started. So first of all, what do I mean by divisibility? Right? What do I mean by divisibility? Right? Now, if you ask me, is 1, 2, 3, 2, 1 divisible by 11? Right? If you ask me this question, is it divisible by 11, right? So one way to do it is the standard snake technique, like I call it snake. This is a standard snake technique. You divide, right, like this, and this is remaining. So if you have a remainder, then it is not divisible. If the remainder is 0, then it is perfectly divisible. So you can write 1, 2, 3, 2, 1 as 11 times some number plus 1. We are not worried about the quotient. We are not worried about the quotient. We are worried only about the remainder. 1, 2, 3, 2, 1 leaves 1 as remainder when divided by 11. But see, like language wise, it is so lengthy. What am I saying? 1, 2, 3, 2, 1 leaves 1 as remainder upon division by 11. Right? So there are three important numbers in this statement. 1, 2, 3, 2, 1 is an important statement. 1 is an important statement. Is important number. 11 is an important number. 1, 2, 3, 2, 1. What do you call 1, 2, 3, 2, 1? It is called dividend, isn't it? This is called divisor. And this is called remainder. Right? Right? Am I making sense here? I should, because there is nothing new in it. Do you all agree? Do you all agree that this is what we call them? Now, in pure mathematics term, in abstract mathematics term, in non-routine mathematics term, in Olympiad mathematics term, we call it 1, 2, 3, 2, 1 leaves 1 as remainder upon division by 11. So we represent this whole situation like this, right? And we say a number A divides B if B is equal to n times A. So basically we are saying remainder is 0. Remainder is 0. Right? We are saying remainder is 0. Right? Right? Remainder is 0. And B equals NA. N and A are divisors of B. Now there is a problem here. Suppose if this number is too huge, 10 digits, 12 digits, let's say 100 digits, then solving using the conventional method will not be appropriate. Let alone appropriate, it will not be optimal. For sure, it will not be optimal, right? We need certain methods for certain divisors, right? We need certain methods for certain divisors to help us ascertain if a very big number is divisible by them or not, right? And that is why we study divisibility rules. That is why we study divisibility rules, right? That is why we study divisibility rules, right? I hope you have written it, right? You can simply write UDAN once you have written it. In all my lectures, you need to attend by with a very good sitting posture, and you should not be distracted because these lectures are of very superior quality. In long run, in some times only in this lecture, we will be dealing with very high concepts, with very high level concepts. So your focus should be here, nowhere else. Okay? 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 Perfect. Then let's write certain rules. Let's write certain rules. Divisibility theorems. Divisibility theorems, right? Important theorem is if A divides B, A divides C, then A divides MB plus NC. This is a very intuitive thing. What am I saying? Essentially, A is divisor of B, A is divisor of C, right? So I can write A as P times B as per the rule which we discussed on the previous slide. I can write A equals, since A divides, this is the symbol of divides, right? When I'm saying A divides B, then B equals P times A, C equals Q times B. Now what is this number? Let's call it N, capital N. Capital N is MB plus NC. Now let's substitute the value of B and C. What is B? B is PA. What is Q? What is C? Q times B. If you, here also it will be A, because we have to see, like, A is the divisor overall, right? So PA and QA. So can you see that you are being able to take A common? And again, by this rule, you can see A is written here, N and A both are divisors. So can you say that, okay, A divides N? So this is the proof of it, and it is required. This type of reasoning is always required. Majority of the students understand the concepts of number theory, but they do not understand the proof. The proving is very much essential, especially at the later stages of mathematics Olympiad, that are RMO and INMO. In RMO and INMO, your reasoning should be very, very perfect. So you need to understand it like this. Otherwise, there is no point. Otherwise, there is no point. Otherwise, there is no point. Okay. I hope I am making sense. I hope I am making sense, guys. Right? Perfect. So there is a corollary of it. What do you mean by corollary? Logical conclusion of a statement. Right? So if A divides MB plus NC and A divides B, then A also divides C. Right? What I am trying to say, if A is dividing this sum and A individually divides B as well, then A divides C. This is a very, very important thing. For divisibility, it is very important. Right? For example, if I have 5P is equal to 25Q plus R, right? Then see, 5 is dividing this number, 5 is dividing this number. What I am trying to say here is 5 is dividing this whole number, 5 is dividing this. It implies 5 also divides R. It implies 5 also divides R. This is a logical conclusion. Right? This is one example. See, like, we use this. We 100% use this. We 100% use this. Right? Please note it. It is very, very important. And the next page is going to be very, very important too. The next page is going to be very, very important too. Okay. Please note it down, guys. Okay, perfect. Right? Now, let us deal with this question. Prove that sum and difference of two numbers have same parity. Now, what do I mean by parity? See, like, parity is basically odd or even. The number is odd or even. So odd and even are pair. Every natural number, every integer for that matter, is either odd integer or even integer. 0 is an even integer. 1 is an odd integer. -1 is an odd integer. -3 is an odd integer. So this is a concept which is related to integers. Now, what is the meaning of this question? If you have two numbers, right, you either add them or subtract them. If after adding you are getting odd number, then after subtracting also you will get odd number. If after adding you are getting even number, then after subtracting you will get even number, for sure. This is the concept. This is the concept, right? This is a very, very important concept which is used everywhere, Okay, and I will give you a very amazing problem out of it, which is of the level, which is I think like of the level of RMO for sure. Let's do it, guys. Let's do it. Let's do it. Solution. If you want to try, you should pause the video and definitely try. But I am going to tell you the amazing solution to this problem. Prove that sum and difference of two numbers have same parity. So we are going to do it with the help of contradiction, right? Contradiction. We have taken two numbers m and n, and we are saying that m plus n is even and m minus n is odd, right? We are saying this thing. So what we are essentially saying that m plus n is even. So we can represent it with 2p, right? Because all even numbers are perfectly divisible by 2. Now what we are saying is that m minus n is odd, which means that m minus n leaves 1 as remainder upon division by 2. This is the definition of odd and even. Even is perfectly divisible by 2. Odd is something which gives 1 as remainder upon division by 2. 3 gives 1 remainder, 5 gives 1 remainder, so on. Now if you add them, you get 2m equals 2p plus 2q plus 1. Right? Now according to the rules which we have already studied, this is divisible by 2, this is divisible by 2, hence 2 should divide 1, which is a contradiction. It is a contradiction, right? And hence, since it is a contradiction, hence both have same parity, right? Both have same parity. Parity means either both of them are odd or both of them are even, right? So in my experience, students do not understand it like this. Sir, this proof is too abstract, right? So always in number theory problems, always take examples first. What is the problem all about? Because when you take the examples, you understand the problem, and the first step to solve a difficult problem is to correctly understand it. It is a very important thing. So let's take any example. M plus n, I am making a table. Let's take both of them as even. What is the sum? Even. Difference. All I have to do is to check the parity. If the parity here is 0, that is, it is even, then the subtraction is also even. Let's take this as odd and this as even. This is odd, subtraction is also odd, integers. Let's take this as even, this as odd. Again odd, odd. Let's take both of them as odd, right? See, both of them have same parity. 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 In all the examples that you were able to take, these two numbers are of the same parity. So now this is how we have understood the problem. This is how we have understood the problem. And then once we understand it, this is the abstract form. What do I mean by abstract form? General proof. This is a general proof. Getting my point? This is the general proof of it. This is the general proof. Okay. Am I making sense, guys? Am I making sense to you? Am I making sense to you guys? I hope I'm making sense. Am I making sense to you guys? Perfect. Okay. So this is about divisibility of 2, right? So this is the basic about divisibility, right? Now, this is a very important problem. Prove that m n belongs to natural number cannot satisfy 2m plus 1 into 2n plus 1 equals, or let's just say m square minus n square equals 6. Cannot satisfy. Now m and n are natural numbers, right? What I'm trying to say, 6 cannot be represented as difference of two perfect squares. I'm simply saying this thing. So this question can come it like this also. So in these type of problems, what we have to do, we have to approach through divisibility, basic rules of divisibility, right? If you want to try, you can pause the video and you can try, right? If you want to try, you can pause the video and you can try. Now, this is, if I factorize it, m plus n and m minus n is equal to 6. Now see, these are the two numbers. Addition of two numbers and subtraction of these two numbers. So either both of them will be odd, which cannot be equal to even. So this case is rejected. If both are even, it has 2 as one factor. So in the multiplication, you will have two factors of 2, right? What I'm trying to say here is, just take any two numbers which are divisible by 2. Let's take 6 and 18. So if you multiply them, you have 2 to the power 1 here. You have 2 to the power 1 here also. So in their multiplication, you will have 2 powers of 2, right? So even into even is actually, should have 2 powers of 2. But 6 only has 1 power of 2. So this is also a contradiction. It implies no solution, right? So these are certain advanced applications, but these applications are important so that you understand the basics of divisibility, right? So that you understand the basics of divisibility. Okay. Right? Perfect. Let's do this question. Let's do the next question. Let's do the next problem. Right? This is the last one, and then we will go on and study divisibility rules and cyclicity, right? This is the next question. Prove that a 7-digit number is divisible by 9 only if its sum of digits is divisible by 9, right? So essentially what I'm trying to do, I'm trying to prove the divisibility test divisibility test of 9 of 9. We are trying to prove divisibility test of 9. Okay, we are trying to prove divisibility test of 9. Okay, let's try to do this. Let's try to do this. Let's try to do this. Now you need to understand carefully what the question is asking. Right? Like I said, think of a number which is divisible by 9. Okay, sir, 225 is divisible by 9. Now, what is its sum of digits? 2 plus 2 plus 5, which is equals 9. Yes, the sum of digit is also divisible by 9, and hence it should make sense. Hence, it should make sense. So, let's try to prove it. Now, it is a 7-digit, like 7-digit number is just a representation, right? So, first of all, 7-digit number is represented like this, right? Now, when you represent number like this, it is called decimal system. Decimal system, which means that this number can be expanded in the form like this, expanded form, right? Why it is called decimal digit? Let me explain you. But first of all, let me write it. Let me write it. Right? You must have seen this expanded form. Now here, these AIs can be 0, 1, 2 to 9. So since AI has 10 possible values, 0, 1, 2, like these are digits, right? And since it is a 7-digit number, so we can say that A1 will not be 0. But let's leave that aside. AI can take 10 values, 10 possible values. What do we call 10 in Greek language or Roman language, whatever you call it? Deci, right? Dec means 10. So that is why we call it a decimal system, since we are using 10 digits. If you represent any number, right, whatever be the number, your Instagram followers, whatever the number you can choose, you use 10, out of the 10 digits, you use certain digits to represent that number, right? And that is why it is called decimal system. Now, if you see this number, I can write 10 to the power 6 A1 as this, 999 A1. And let's write A1 here, plus 99999 A2 plus A2, 9999 A3 plus A3, 999 A2 plus A2, oh sorry, A4, my mistake, 99 A5 plus A5, 9 A6 plus A6, and then plus A7, right? If you see, this is my whole number. Now, if you carefully observe, this number is divisible by 9. 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 And this number is divisible by 9. Since this whole thing is divisible by 9, I can say that this sum is also divisible by 9. Right? According to the rule which we have just written. Right? Divisible by 9. And that is what we needed to prove. This is what we needed to prove. Divisible by 9, right? Sum of digits. This is sum of digits only. We write it as Sn. Sum of digits is represented as S of n. Right? Where n is this number. So, see, if you carefully see this proof, this can easily be extended to 8 digits, 9 digits, or any number of digits. Right? And hence, I am of the 100% opinion that this proof, like you will be able to use this proof to actually write the general proof of it. If you have written it and if you are seeing this lecture in recording, do leave a comment here so that I know that you are learning from these lectures. Please do it. Okay. Okay. Yes, Yuvika, Yash. Right? Now, yes, like you are saying, you are rightly saying, sir, divisibility test of 9 is very simple. We have studied in class also. But what about divisibility test of 11? So should we do divisibility test of 11? Should we do divisibility test of 11? Actually, in one of my lectures, I taught you the concept of, if you have seen that lecture, I have taught you the concept of divisibility test of 11 also. Right? If you have written it, just write UDAN. Perfect. So guys, these lectures are every Monday. Every Monday we schedule these lectures, and all you have to do, if you are not getting the notification, it means you are not on this channel. Right? Right? So first of all, let's write the divisibility test which you need to remember. 2. Last digit should be divisible by 2. Right? Should be divisible by 2. By 2. 2 to the power k. Last k digits should be divisible by 2 to the power k. What does this mean? That if you want to check 8 for 8, then last three digits should be divisible by 8. And it is not something which is like random. It is not random, right? Why this work? Because 2 to the power k or 5 to the power k, same, right? Should be divisible by 5 to the power k. Why does it work? Because if you have any number, let's assume that you have this 6-digit number, right? You can write this number as 1000 time ABC plus DEF. This is a 3-digit number. These are digits. So now this number, because of 1000 is 2 to the power 3 into 5 to the power 3. It is divisible by 2 to the power 3 and 5 to the power 3, which means that these 3 digits are immaterial. All you have to check is these 3 digits, right? So let's take an example. 729,120. Is it divisible by 8? These digits do not matter. Just check for this 120. 120 is 8 times 15, and hence this whole number is divisible by 8. So this is the general proof of 2 to the power k or 5 to the power k, right? We check for these many digits. For 3 and 9, we do sum of digits should be divisible by 3, 9. If we talk about, see, like we have done 2, we have done 3, we have done 4, we have done 5, we have done 6. For 6, you have to check divisibility by 2 and 3. So basically, its last digit should be divisible by 2 and the sum of digits should be divisible by 3. 7, we do not study. 8, we have studied. 9, we have studied. 11, very important. Sum of digits at even places at even places minus sum of digits at odd places should be equal to 11 times q. Should be divisible by 11, right? It should be divisible by 11, right? 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 Yes, obviously this is in my book. Right? So let's try to do 11. Let's try to do 11, right? Divisibility test of 11. And again, I am going to explain you first. So let's take two numbers. 2, 3, 4, 5, 7. So 2 plus 4 plus 7 is how much? 13. 3 plus 5 is 8. Right. Now, this is first place, this is second place, this is third place, this is fourth place, this is fifth place, this is sixth place. So these are odd digits. Let's take the sum at odd digits. This is equals to 13, isn't it? Let's take sum at even digit. 3 plus 5 plus 5, 13. This implies that the number is divisible by 11. Divisible by 11. Now, why is it working? I'm very curious to know this. Why does it work? Right? So again, I will write it as this. Right? 2 into 1, 2, 3, 4, 5, right? Plus 3 into 1, 2, 3, 4 plus 4 into 1, 2, 3, 5 into 100, 7 into 10 plus 5, right? Now, what do I know? That if I have even times 9, then it is divisible by 11 for sure. So what I am trying to do here is that I can write 1 lakh as 99990 plus 10. Because see, like, I always have to make 9 even number of times. And then 1, 2, 3, 4 as 9999 plus 1. This is the rule which I am going to follow. So 2 into 99990 plus 10 plus 3 into 9999 plus 1 plus 4 into 990 plus 10 plus 5 into 99 plus 1 plus 7 into 10 plus 5. Okay? Okay? I am making sense here. Now, very simple. Let's isolate these numbers which are divisible by 11, right? Once you do that, you are left with 2 into 10 and I am representing them by 11 cube, which is divisible by 11. So I am left with 2 into 10 plus 3 into 1 plus 4 into 10 plus 5 into 1 plus 7 into 10 plus 5 into 1. Right? This is divisible by 11. Now, I will add 2 here. I will add 4 here. I will add 7 here. And then I will subtract minus 2, minus 4. I will do this. If you carefully see, this number now becomes 11 times 2, this number becomes 11 times 4. This number becomes 11 times 7. And hence, this number is also divisible by 11. And what are you remaining with? You are remaining with this 3. You are remaining with this 5. You are remaining with this 5. And you have this. So basically, since this is divisible by 11, this is divisible by 11, this should also be divisible by 11. And this is the proof of divisibility of 11. Now that you have done it using an example, you can replicate this proof using general values. For example, you can just assume them as A1, A2, A3, A4, A5, A6, and likewise, you can prove it. This is the same mechanism which you are going to do, and this is your homework as well. This is your homework as well, right? Please note it down. Please note it down. This is the general proof. Right? Yes, if you have secured 75 marks in RMO, you can directly get admission in SRG batch. Perfect. Right? Now let's do a problem related to 7. Let A and B are 2 digits so that this is 3 marker. This is 3 marker. So that 2, 3, A, B, 5 is divisible by 7. Is divisible by 7. Find number of such numbers. Right? This is 3 marker. As per the new difficulty of IOQM, if we take old difficulty of IOQM, then this is 2 marker. But as per the new difficulty of IOQM, this is a 3 marker. Let A and B are 2 digits so that 23AB, 23AB5 is divisible by 7. Find number of such numbers. So basically, you have to find number of 5-digit numbers in which first digit is 2, second digit is 3, third digit is something, fourth digit is something, and next digit is 5. Right? So such 5-digit numbers which are divisible by 7. Please try. Please try. Please try this. Usually such problems come with a warning, do not try this at home, but I'll say let's try it at home. That's all, boys, girls. Tell me, please. So let's do it. Let's do it. If you want to solve it, you can again pause it. And again, I am going to tell you the importance of proving. Right? I told you the proof using the expanded form. So, can I write this number as 23005 plus 10 times AB, which is tan A plus B? Right? How did I come to this conclusion? Very simple. I am writing this in expanded form. Right? So I just simply added these numbers and like this. So let's talk about 23,005. Now there is some manual work here. If I divide 23,005 by 7, I get, again I'm not worried about the quotient. Quotient is not going to help me. 45. So this number leaves 2 as remainder. So I can write it as 7q plus 2. Now 100a can be written as 98a plus 2a. 10b can be written as 7b plus 3b. Right? This is divisible by 7. This is divisible by 7. This is divisible by 7. It implies 7 should divide 2 plus 2a plus 3b. Am I making absolute sense here, guys? This is the actionable information. This is the actionable information. This is that information on which you can act and you can find the value of A and B. Otherwise, it will be hit and trial, isn't it? It will be hit and trial only. It will be hit and trial. Right? One way to see, I am going to give you an alternate solution also to this. I am going to give you an alternate solution to this also. Right? I'll give you a smart solution to this, but it will require it requires some brain power. But this is the general way to do it. This is the general way to do it. Remainder is 3, not 2. Okay, remainder is 3. So you can write 3 here, you can write 3 here. My bad. My bad. You can write 3 here, you can write 3 here. Okay? Perfect. 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 Is it okay now? Is it okay now? Is it okay now? Is it okay now? Perfect. Now, one way to do it is using indeterminate equation. Right? I am going to write this as 7, 3 plus 2a plus 3b equals 14, 3 plus 2a plus 3b equals 21, 3 plus 2a plus 3b equals 28, 3 plus 2a plus 3b equals 35. Now, why it will not go above 35? Let's see the reasoning. Why? One more, it can go further higher also. But see, A and B can be highest 9. So the highest sum can be 48. 3. 2 times 9 is 18. 18 plus 3 is 21. 21 plus 27 is 48. So we have to take till 42. I am going to take here. Or let's use the other page. Let's use the other page. We do not have dearth of resources. So 2a plus 3b plus 3 equals 7 means 4. Right? So you can see here 2, 0. That's it. This is the only solution. Right? This is the only solution. Right? 2a plus 3b. See, right? My question was this. 7 times q. So if I take q as 2, which means 14. So this becomes 11. Right? Now, we have to find it actually. Yes. So if b is 1, a is 4. And then what do? We add, I think it will be one solutions only. No. This. 6, 1, sorry. You add 2 here, 1, yes. 2 solutions here. Because if you again, see, like I am solving it using indeterminate. What was the technique here? You find one solution and then you subtract the coefficient here and you add this coefficient here. Now the next is 2a plus 3b equals 18, which is fairly simple because I can start with 6 here. 0, 4, 3, 2, 6, 0, 9. Right? One solution here, two solution here, four solutions here. Then 2a plus 3b equals 25. Now this is going to be tricky. This is going to be tricky. This is actually going to be tricky. Right? But let's do it anyway. 2, 3. If I take b equals 1, then my a is coming out to be 11, which is not possible. So let me start with b equals 3. Right? So that is a 9. 25 minus 9, a becomes 8. And then simply you have to subtract coefficient of 3 here, coefficient of b here, right? Like this. Okay. So these are the three solutions. Now 2a plus 3b, 35 means 32. Again, b equals, so this is even, so b has to be even. So b equals 4, not 4. b equals 6, 18. This becomes 14, 7. Right? This becomes 7. And then 4, 8, 1, not only these two solutions. Right? 2a plus 3b, last is 39. Last is 39, right? So this is divisible by 3, hence a has to be divisible by 3. So this becomes 9, 18. 9 2s are 18. If you subtract 18 here, this becomes 7. Right? So these are so high numbers. So this is going to be a unique solution. Unique. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 solutions. Do you agree here that these are the solutions? Do you agree here? Do you agree here? A equals 1, B equals 3. A and B cannot be same, so 5, 5 is not a possibility. Where we have written it? Where have we written it? Where have we written that A and B cannot be same? Where have we written it? Don't presume anything. You cannot presume anything. Right? 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 So these are 1, 2, 3, 4, 5, 13 solutions. Now, see, this is a general method, but there is a way. There is a way. Right? There is a way. There is a way. Let us find the smallest number. Let us find the smallest number which is divisible by, so let's take this number 23065. Right? Is it divisible by 7? 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 Please tell me, is it divisible by 7? 23065. Is it divisible by 7? The magic is about to happen. Don't worry, the magic is about to happen. Now, if I add a number 70 to it, this is divisible by 7, this is divisible by 7, and since I have 0 here, it will not alter this digit. It will not alter this digit. It will alter only these two digits. So I simply have to add 7 here. Just keep on adding 7 to these two digits. 13. Right? And keep on adding till you get 2 digits. See, I'm simply blindly adding right? Keep on adding till you have 3 digits, 2 digit. 7975, right? How many numbers did we get? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Which means I have done a mistake somewhere. I have done a mistake somewhere. 9, 0 is solution, 8, 3. Or did I get 4 solutions? 0, 6, 1, 3, 2, 0, 2, 7. Where is 2, 7? 2, 7, 3, 4. 3, 4. Where is 3, 4? 3, 4. 4, 1, 4, 1, 4, 1, 4, 1, 4, 8. Or did I count it wrong? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 14 solutions. 9, 0, 8, 3. Where is 8, 3? 7, 6. Where is 7, 6? 6, 9. Where is 6, 9? Oh, my 6, 9 solution is missing. 15. 2A, 12. 6, 9 should come where? Where 6, 9 should come? Six, 9 solution should come where? I think here. I missed here. Is it? No. 2A, 12 plus, oops, 6, 9 should come here. You have to subtract 3 here and add 2 here. So it's 14 solutions, right? 14 solution, my mistake. So 14 solution, and you are getting 14 solutions here also. Can you check? Can you check? Sir, they all are divisible by 7. See, like, you need to understand this thing, that if this is divisible by 7, this is already divisible by 7, I am adding a number which is divisible by 7, right? Which is divisible by 7. No, there is no problem related to divisibility test of 7. Divisibility test of 7 is simply out of sorts, right? Perfect. Perfect. Right? Please write UDAN. If you have understood it, please write UDAN, understood, done and noted, so that I can move on to the next problem. I can move on to the next problem. Perfect. Now, let's talk about what do I mean by cyclicity? What do I mean by cyclicity? And cyclicity is something which I am simply going to define, but we are going to continue this in next lecture. So, last digit. What are the last digits, right? Basically, cyclicity means we have to ascertain the last digits. So, if number is of the type 10q, 10q plus 1, 10q plus 2, 10q plus 3, 10q plus 4, 10q plus 5, 10q plus 7, 6, sorry, 10q plus 7, 10q plus 8, 10q plus 9, right? So these are the only 10 possibilities. Either the last digit is 0, either the last digit is 1, either the last digit is 2, either the last digit is 3, and so on, right? So this is, and here I am going to write powers. If power is of the type, this is last digit, this is powers, right? This is 4k plus 1, this is 4k plus 2, this is 4k plus 3, and this is where I am going to write cyclicity. And then with example I am going to tell you what is the meaning of cyclicity. So 4k, any power, right? And here some examples also. If you take any power of 10 or any number with last digit 0, last digit will definitely be 0, right? So since it is repeating for every integer, it is repeating, right? So what do I mean by 4k, 4k plus 1, 4k plus 2, 4k plus 3 here? The power is divisible by 4. The power is leaving 1 as remainder upon division by 4. This power is leaving 2 as remainder upon division by 4. This power is leaving 3 as remainder upon division by 4. Right? This is what we need. This is what we need. Okay. So 0, 0, 0, 0. Now, if you talk about 10 cube plus 1, you will find that the last digit will always be 1. See, 11 to the power, let's say 5. It will be, the last digit will always be 1. So, this cycle is 1, this cycle is 1. But this is where the fun is. 10 cube plus 2. And to analyze it, just think of the smallest number with last digit 2. That is 2 only. What is 2 to the power 1? What is 2 to the power 2? What is 2 to the power 3? What is 2 to the power 4? What is 2 to the power 5? 2 to the power 5 is 32. 5 is of the type 4k plus 1. 5 is of the type 4k plus 1. So last digit will again be 2. So this cycle is repeating. Now what is the length of this cycle? 1, 2, 3, 4. Right? If you talk about 3, 3 to the power 3, 3 to the power 1 is 3, 3 to the power 2 is 9, 3 to the power 3 is 7, 3 to the power 4 is 1, 3 to the power 5 is 243, which is again 3, again the cycle is 4. If I talk about 10 cube plus 4, 4 to the power 1 is 4, 4 to the power 2 is 16, 4 to the power 3, that is 64, is 4, and again 6. So 6, 4, 6, 4, the cycle is 2. So because it is repeating in pairs, right? 5, again 5, 5, 5, 5, cycle is 1. 6, 6, 6, 6, 6, cycle is 1. Right? What is 7? 7 to the power 1 is 7. 9, 3, 1. 4 here again. 8, 8 to the power 1 is 8. 8 to the power 2 is 64. 2, 6. 4. What is 9? 9 to the power 1 is 9. 1, 9, 1, that is 2. So this is the cyclicity. This is the cyclicity. It repeats its unit digit after every fourth power. Fourth power, 2 power. This is such a beautiful pattern. 1, 1, 4, 4, 2. 1, 1, 4, 4, 2. Such a beautiful pattern, isn't it? Such a beautiful pattern, isn't it? Right? Right? So in the next lecture, we are going to do problems based on cyclicity, and we are going to take it to a very high level. Right? We are going to discuss problems on divisibility as well. Right? So till the time we meet, like in the next lecture, which is going to happen on Monday, 5 p.m. again, please make note of this schedule. I am going to take these lectures till mid of January, after which I am going to leave you for your board exam, your school examination. Then we'll resume this series in the month of April. But we are going to do it. My aim is to complete the basic of everything by the end of January, so that we can start the proper IOQM or RMO, whatever you want to call it, in the month of March or April. Right? Because it is 100% certain that IOQM is going to happen in the month of September. In first 10 days of September, it is going to happen. So practically, you have 8 months of next year and 1 month of this year, which means total 9 months, right? So I hope you like the video. If you do like it, please do share it and leave your comments. This is a very important initiative taken by us by taking these lectures in English. Taking lectures in English is very hard on me as well, because my mother tongue is Hindi. And I'm taking this effort so that my teaching can reach to those learners also who prefer only English language. So if you know a person who has lack of content in English and he is not able to find English lectures of IUQM, please do recommend this playlist. I hope you like the video. If you do like it, please do share it. Let's crack it.